For weeks, Comet C/2025 A6 Lemon has been a familiar and comforting presence for skywatchers across the northern hemisphere, a small greenish wanderer drifting through the night and offering observers a cosmic companion to follow as it brightened and faded. Many amateur astronomers spent night after night photographing it, tracking its subtle changes, and watching its long, ghostly tail grow longer as it glided against the stars. But now, as all comets eventually do, it has slipped away into the southern sky, leaving northern observers staring up at an empty patch of darkness where it once hung. That sense of mild loss, of an old friend suddenly vanishing after weeks of companionship, is something every skywatcher understands. When you spend so many nights looking up at something so distant yet so strangely personal, its departure feels like the closing of a chapter, as if the sky itself has quietly changed the subject. So naturally, people have begun to ask the same question. Now, what? What do we look at next? The universe, thankfully, is generous, and it rarely leaves stargazers without something new to marvel at. And indeed, another comet is out there, still clinging to the northern sky, though it is admittedly far fainter and much more challenging to observe than Lemon ever was. Yet this faint smudge of light is profoundly special, far more extraordinary than it appears at first glance, and its story is one that astronomers will be talking about for decades to come. Unless someone has been living completely cut off from every scientific conversation, buried in a bunker or hiding under a rock on Mars, they will already have heard the name, Comet 3 I/Atlas. Over the past several months, it has dominated astronomy headlines, appearing in news reports, scientific discussions, and social media posts alike. The fascination surrounding it has nothing to do with its brightness or beauty. In fact, visually, it has been rather underwhelming. What makes 3 I/Atlas remarkable is its origin. Unlike Lemon, or Hale-Bopp, or Halley, or any of the famous comets that have swept past Earth throughout history, 3 I/Atlas does not belong to our solar system at all. It is, in a very literal sense, a visitor from the stars. Astronomers classify it as an interstellar object, more specifically an extrasolar comet, meaning it was formed around a completely different star in a planetary system that may no longer even exist. Its birthplace lies somewhere deep in the distant reaches of the Milky Way, in a corner of the galaxy we may never pinpoint. It has been wandering the interstellar void for millions, perhaps even billions, of years before the gravitational pull of our sun finally tugged it into our cosmic neighborhood for a brief and fleeting visit. Because it is not bound to the sun, 3 I/Atlas is not following the typical looping orbit we associate with comets. It is not a returning traveler like Halley or a long-period comet that will eventually come back after thousands of years. Instead, its trajectory is hyperbolic, meaning it entered the solar system at tremendous speed and will leave it again, never to return. It is merely passing through, cutting across the solar system like a stone skipping across water, before shooting back out into the darkness between the stars. That alone would be special, but this comet carries with it the potential to answer profound questions. Its composition, its surface chemistry, its dust, and even the gases it releases all carry clues about what comets were like in other star systems eons ago. Some estimates suggest 3 I/Atlas might be as old as 7 billion years, older than the Sun itself by more than 2 billion years. That means this object formed at a time when our solar system did not yet exist, when Earth was still an unimagined possibility, and when the galaxy was a very different place. To astronomers, that makes it almost like a time capsule from a forgotten world orbiting a long-lost star. But the excitement surrounding 3 I/Atlas is not shared only by scientists and professionals. Unfortunately, as often happens when something unusual wanders into our skies, conspiracy theories quickly began to swirl. Social media has been buzzing with claims from self-appointed experts and alien-obsessed personalities announcing that 3 I/Atlas is not a comet at all, but rather a disguised spacecraft, or a probe, or even a warning signal. These ideas, though imaginative, have absolutely no scientific basis. The comet behaves exactly the way natural interstellar objects should behave: its chemical signatures, its speed, its brightness curve, and its coma all follow well-understood physical processes. Yet in an era where misinformation spreads faster than telescopic data, many people have heard speculation that sounds dramatic but collapses under even the slightest scientific scrutiny. This situation is reminiscent of a humorous moment from the end of the film The Martian, where astronaut Mark Watney jokes to his class of new astronaut candidates that yes, everything they've heard about his survival using potatoes grown in his own waste is true, but also that he is never going to discuss it again. In the same way, it feels necessary to acknowledge the wild theories surrounding 3I/Atlas, dismiss them firmly, and then move on, because the truth is already more astonishing than any conspiracy could be. As 2025 moves toward its end, astronomers are racing against time to observe as much of a comet as possible before it fades into the outer reaches of the solar system. Every night of observation counts. Professional observatories are gathering spectral data, measuring its dust production, and mapping the unique signature of its gases. Amateur astronomers with sensitive equipment are recording its faint glow, knowing that in a matter of months it will be too far and too dim for even the most powerful telescopes to study. The comet's motion is a reminder of how fleeting astronomical opportunities can be. These objects, these icy wanderers crossing inconceivable distances, offer only brief glimpses into their secrets. If we fail to observe them when they pass, we lose the chance forever. Yet for all the scientific urgency surrounding it, the emotional side of this event should not be ignored. There is something beautiful, almost poetic, about a lonely comet from another star drifting silently through our sky. It reminds us how enormous, how ancient, and how interconnected our galaxy truly is. Somewhere long ago, a star formed planets and comets of its own, and one of those comets was flung out by gravitational chaos into eternal exile. It wandered for ages until by pure chance, it brushed past our sun and allowed us a glimpse into a story billions of years in the making. Once it leaves, it will continue wandering through the dark, untouched and unseen, maybe never passing another star closely again. Perhaps, millions of years from now, another civilization might detect it and marvel at it just as we do today. And so, while northern skywatchers may lament the loss of Comet Lemon as it drifts southward, the heavens have provided them with something far rarer, a cosmic visitor from beyond our solar system, ancient and mysterious, faint but extraordinary. Observing it requires patience, dark skies, and often powerful equipment. But for those who catch even the faintest glimpse, there is something humbling in knowing they are witnessing an object that has traveled farther than anything else visible to the naked eye. As the year progresses and the comet slips away for good, astronomers will continue to analyze every scrap of data, hoping to learn something new about the origins of planetary systems, the early galaxy, and the processes that shaped worlds beyond our own. And in the end, even if the comet fades unnoticed by most, its brief visit will leave a lasting mark on our understanding of the universe, a reminder that we are not isolated in space, that the galaxy is constantly sending us relics from distant stars, and that sometimes the most extraordinary objects are the quietest ones, visible only as a dim whisper against the backdrop of the night.